Hi friends, this is one more interesting problem. Here we need to find the current passing through 2 ohm resistor. So this is the current. So we need to find this current. Yeah, this current has to be found out. Yes, I. So how to find this? So here I like to use a nodal analysis. So nodal analysis. So according to nodal analysis, first we need to identify the nodes. So let me identify the nodes here. So the first node is, yeah, this is one node. Let me call it as the node 1. So this is node 1 and this is second node, node 2, and this is third node, node 3. Of course this is fourth node, or we can make it as reference node or the ground node. So definitely the voltage across node 1 is V1 and voltage across node 2 is V2. The voltage across node 3 is V3. Okay. Now let us see what are the different equations we can find out. So let me write KCL, Kirchhoff's current law, at node 1. So what will happen? So Kirchhoff's current law means we feel that my node voltage is more compared to all other voltages. So definitely the current is moving in this way and this way. Simply. So what is this? This is the current. So this current is in opposite direction with 5 ampere. So I can say one thing. So this is minus 5 and the next one is minus 5 plus V1 minus V2 divided by 2, that means this current, capital I, and the one more current is V1 to one more current passing from V1 to V3. Actually this is the voltage source, so we are unable to find out the current passing through this voltage source. So what we need to do? So this is the problem here. So these type of nodes, that means in between two nodes there is one more voltage source. These type of nodes is called super node. So let me identify the super node here. Please mark here, this is called super node. So from this node to this node, you can call this part. Yeah, this is called super node. The whole thing will be looking as a node. Then what will happen? Obviously it is two equations connected to node 1 is over. Similarly we need to find another two equations connected to node 3. Okay, so obviously we are at node 3, so the current will flow in this direction. So this is our assumption. So simply add with this, so it should be plus 8 ampere plus V3 divided by 2.5 ohm, which is equal to 0. So this is the, yeah. So I have taken this by using these three equations. I have converted into matrix form. So matrix form means simply we need to take the multiple of V1, V2, V3, and this is the constant column. So if you can see the equation 1, you can simply say the multiple of V1 is 2.5. So I can write here, and multiple of V2 is minus 2.5. So I can write here. Multiple of V3 is 2. So I can write here. So in this manner, I have written all the three equations in matrix form. Okay, of course I have solved the third equation also in this manner. You can just observe it. That's all. So now according to matrix method, I can solve now for V1. So I am proceeding with the solution of V1 now. Yeah, so it is minus 2.5. So it is minus 3.5 and minus 0.16 2, 0 and minus 1 modulus divided by modulus of 2.5, 2.5, 1 minus 2.5 minus 3.5 minus 0.16, 2, 0 and minus 1, which is equal to okay, now it is very easy for us to get the debt based on the first column. So let me go ahead with that. Minus 15 into so minus of minus, it's plus 3.5 into 1 is 3.5. So this is 3.5 minus minus 0.16 into 0 is 0, so no need to worry about that. And next, this with this 40 minus of minus 40, so it will be plus 40 into, so minus 2.5 into minus 1, it is 2.5 minus minus of minus, it will be plus, so 0.16 into 2 is 0.32 divided by, of course 0 into something will be always be 0, so divided by. Now it is easy for us to go ahead with the third column, so let me go ahead with that. 2 times of 2.5 into 0.16, so let me solve here. It is 0.16 into 2.5, so 2.5 means it is 10 by 4, it is 0.04 into 10, which is equal to 0.5. Okay, so its value is 0.4. So 2.5 into minus 0.16 is minus 0.4, and minus of minus is plus 3.5. That's all for this thing. Minus 0 into something will be 0, and minus 1 into 2.5 into minus 3.5. Okay, 2.5 into minus 3.5, 2.5 into 3.5 is 5. Okay, let me take the calculator, we finish it off. So 2.5 into 3.5, yeah, it is 8.75. So minus is always there, minus 8.75, and minus of 2.5 into 2.5 is 2.5 into 2.5 is 6.25, and minus of minus, it is plus 6.25. That's all. So the numerator value is simply 15 into 3.5, 15 into 3.5, yeah, it is 52.5, and yeah, 52.5. Let me write it, no problem. So this is the solution for V1. So we have done the solution for V1, then the value is come out to be 58.8. Okay, let us solve it for V2 and V3 also. So let us go ahead with the second one, that is V2. So V2, now we are trying to find out V2 here. So V2 is equal to modulus of 2.5, 2.5, 1, and the second column should be replaced with the constant column, that is minus 15, minus 40 and 0, and this is 2, 0 and minus 1. So divided by same thing, so that of this matrix, and it was already found to be 1.5. So its value already we found it, it's 1.5. So which is equal to, simply let me go ahead with the third column. So 2 times of 2.5 into 0 is 0, minus of minus 40, so it is plus 40, minus 0, it's 0, and so minus 1 into 2.5 into minus 40, so it is 25 into 4, it's 100, so minus 100 minus 2.5 into 15, so 2.5 into 15, and minus of minus, it will be plus, so 2.5 into 15 is equal to 37.5. So its value is 37.5. That's all. So divided by 1.5, which is equal to, so minus 100 minus 37.5 is 137.5, and which is equal to, even minus is there, minus of minus it will be plus, so plus 80 is equal to 145.5. So this value is 140 divided by 1.5 is equal to 97 volt. So if our job is to calculate the current passing through 2 ohm resistor only, then it is very simple for us. So we no need to calculate V3 also. Okay, but we will calculate V3 also here. After that we will find out the current passing through 2 ohm resistor. Okay, so let me solve this. So it will be like a practice session for us. So let us solve V3 also. So V3 is equal to modulus of 2.5 minus 2.5 minus 3.5 minus 0.16 and minus 15 and minus 40 and 0. So this is the column, okay, constant column, divided by 1.5. So this will be equal to, same, let me proceed with the third column. So it should be minus 15 into, let me write it, minus 15 into 2.5 into 0.16 is 0.4, and 16 into minus 0.4 minus of minus plus 3.5, so this part, and minus of minus plus 40 into 2.5 into 0.16, so this part it's 0.4, same thing, 2.5 into 0.16 is 0.4, so it will be minus 0.4 minus of, yeah, it is plus 2.5, so divided by 1.5. So this will be very easy, minus 15 into minus 0.5 plus 40 into it is 0.4, okay, there is a mistake here, so 1 second. So 2.5 into 0.16 is 0.4, and 0.4 3.5 is 3.1, so this part is 3.1, okay, plus 3.1 and 40 and 0.4, so 0.4 minus 2.5 is 2.1, so this part is 2.1 simply, so this is 2.1, so divided by 15, sorry, 1.5. Now 15 into 3.1 is equal to 46.5, this is in minus, next step, 21 into 4, it is 82, so the second part is 82, minus 82 is equal to 35.5, so the upper part is 35.5 divided by 1.5, so it will be equal to 26.67 volt. Okay, of course it's not necessary for us, anyhow we have calculated the three things, and our job is to calculate the current passing through 2 ohm resistor only. So here the current passing through 2 ohm resistor is V1 minus V2 divided by 2. Okay, that we should be very clear. Yeah, let me write here. So current passing through 2 ohm resistor is current, let me write it as I, which is equal to V1 minus V2 divided by 2. So what is V1? Yeah, 58.8 minus V2 97 divided by 2, which is equal to 58.8 minus 97, 38.2 divided by 2 is equal to 19.1, so which is equal to minus the 19.1 ampere. So this is the answer. So guys, if you have any different answers, please type in the comment window, because network analysis, they may be, we may commit so many mistakes. Okay, so please try to correct ourselves, so that it will be very uh, good sign from our sides, so that we can clear our doubts and we can improve our mathematical skills, because so many mathematical things are involved in it. So they may be, sometimes we may be wrong in getting the answers. Okay, so that's all. So this is for super node type of problem. So please like this video and share this video with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.